Okay, this is AP Calculus section 5.8 through 5.10 test review. This video will cover part 1, the first half of the test review. And we are going to work some new problems in this review, so it's worth watching. And what you'll want available is your sheet that has all the formulas on it, and also have a unit circle handy. You will get the unit circle on the test. Now, I have divided this review into 10 sections, and this video is going to cover the first 5. Now, I'm not talking about the chapter sections. I'm just 10, let's call it 10 topics. And we'll do the first 5 topics. So, first of all, in section 5.8, the first thing that you have to know how to do is evaluate inverse trig functions with the unit circle. Okay, you have to remember your range restrictions. So you will not, the unit circle that you will get for this test won't have these restrictions on it. You'll have to remember it. So for arc sine, that's negative pi over 2 to pi over 2. Quadrant 1 and quadrant 4. You cannot give an answer outside of those quadrants. For arc cosine, of course, that's also true for arc cosecant. Okay, arc cosine 0 to pi. So that's quadrant 1 and quadrant 2. And for arc tangent and cotangent, cosine and secant, arctangent, same as sine, pi over 2 to pi over 2. So negative pi over 2 to positive pi over 2. So again, your answers have to be in quadrant 1 and quadrant 4. Sometimes you'll have to give a negative angle so that you're within this restriction. So let's do a couple of examples. Our first one is find the angle whose sine is negative root 2 over 2. Now if you look at your unit circle, remember it's cosine first and then sine. So negative root 2 over 2, you're going to find 5 pi over 4. That one's negative root 2 over 2. And 7 pi over 4. That one is also negative root 2 over 2. All right, 5 pi over 4 and 7 pi over 4. Now, first of all, both of those are outside the range. 5 pi over 4 is totally out because it's in quadrant 3. 7 pi over 4 is in quadrant 4, so I have to write this in a different way. We can write 7 pi over 4 if we go this direction as negative pi over 4. Okay, it's the exact same thing, and that's how you have to report it, because that number's within this range of negative pi over 2 to pi over 2. You can't, even though 7 pi over 4 is coterminal, it's the same angle, you can't report it that way. You'll count off if you do that. Now let's do one with arctangent. All right, this is a good one. Arctangent of the square root of 3. Okay, arctangent, we've got to report the answer in quadrant 1 or quadrant 4. It's positive, okay, so we do have to remember the ASTC thing. All right, it's positive, so that's going to be in quadrant 1. This is great to remember, okay? If it's root 3, then the angle is pi over 3. So that's within the range restriction. It's in quadrant 1. So that's the answer. If it were the other one, root 3 over 3, that one is pi over 6. Okay, so if you can just remember that, then you won't have to do the sine over cosine thing and possibly mess that up. So really worth remembering on tangent. All right, that's a couple of examples. Just to remind you how to do it. Feel free to rework the homework problems that are like that if you need to. Okay, let's go to section or topic. I'll call them topics. Topic 2 of this section. All right, and that is evaluating what I call layered trig expressions. Okay, an example of that. So this is the thing, still we're in the things I taught you on the first day. Evaluate, let's say we have cosecant of arc cosine of 2/3. Now 2/3 isn't on the unit circle, so if we have that situation, we're going to have to draw a triangle, a right triangle. So call this angle theta. Cosine is adjacent over hypotenuse, so 2 over 3. Now cosecant involves the opposite side, so we're going to need to use the Pythagorean theorem to get that. So we'd have 3 squared is equal to y squared plus 2 squared. All right, 9 minus 4, 5 is equal to y squared, so the square root of 5 is equal to this missing side. So the cosecant of theta is hypotenuse over opposite. That'd be terrible to forget. So that's 3 over the square root of 5. And you do not have to rationalize that. You can leave the radical on the bottom. All right, that is topic 2. Might want to work 1 or 2 of those. Topic 3 is writing layered trig expressions in algebraic form. That's some fancy words. Okay, let's see if I can remind you how to do these. So write in algebraic form cosine of the arc cosecant 2x. Okay, so you want to draw a triangle. All right, cosecant is equal to hypotenuse over opposite. So the hypotenuse would be 2x. This is like 2x over 1, and the opposite would be 1. Cosine involves the adjacent, so I'm going to have to use the Pythagorean theorem. So that would be 2x all squared is equal to x squared plus 1 squared. Okay, so I'm trying to get this adjacent side here. So that's going to be 4x squared, and this is 1. 1 squared is 1. So move that over. Minus 1 is equal to x squared. So take the square root of that. You'd have the square root of 4x squared minus 1 is equal to our adjacent side. right, so what is the cosine of that thing? Well, we know cosine is adjacent over hypotenuse. So the square root of 4x squared minus 1 over 2x. Boom. All right, so that is topic number 3. Okay, topic 4. So solving inverse trig expressions for x. All right, our example for this is arc sine 2x is equal to pi over 4. So we don't like that arc sine sitting in there at all. So what we want to do is get rid of it by taking the sine of both sides. So the sine of the arc sine of 2x is equal to the sine of pi over 4. Sine and arc sine obliterate each other. So you just have 2x. The sine of pi over 4, if you look at your unit circle, square root of 2 over 2. So solving for x, we divide both sides by 2. You'd have the square root of 2 over 4. All right, and then we'll do topic 5, and that will finish out this video. Okay, we're still in section 5.8. Normally, I would have given this lecture on the day that that 5.10b was due. So it would have taken up the second part of class, and then the day before the test, we would finish it up. This topic 6 through 10 will take just a little bit longer. Okay, so topic 5 is derivatives of inverse trig functions. All right, and what you're going to do is use the handout. I'm going to repeat that mantra a lot. Use the handout. All right, there's our handout. So our first example is find y prime if y is equal to arc sine 2x squared plus 2. So we need to find u, and that is 2x squared plus 2. U prime is equal to 4x. And now we're going to use the formula and plug it in. So y prime is going to be u prime, so 4x, divided by the square root of 1 minus 2x squared plus 2 all squared. All right, so you got to get this all correct. You do not have to FOIL that out and simplify it. The back of the book would probably do that. Just leave it like that. You're good to go. Let's do one more of these, and that'll complete this video. Okay, the next example is find f prime of x if f of x is equal to arc secant x squared minus 4. Okay, so again, we're going to use the formula. Here's the formula. U is x squared minus 4. U prime is 2x. So we've just got to very carefully plug into the formula. Okay, and that is U prime 2x over the absolute value of U, x squared minus 4, times the square root, right, of U squared minus 1. So x squared minus 4 all squared minus 1. Now don't get in a hurry and write that all messy. Write it on the test where I can see everything. I can see the squared. I know what's in the numerator, what's in the denominator. You know, don't get in a hurry. Help me out there on that one. So that concludes the first half of the test review. If we have another video, hopefully the second half of the test review we will do in person, but if not, if I do it on video, it'll cover sections 5.9 and 5.10. And I will talk to you then.